Assalamualaikum and hi everyone. Today we will be presenting a topic titled Fish Culture, Achievement and Challenges for the course AQU239 Fish Culture under the guidance of Medabus. Before we begin our presentation, I would like to introduce my team members who have worked together on this project. To make it more interesting, we have prepared a short video. Let's take a look.
With the fans.
This presentation will highlight the major achievements in modern aquaculture, such as technological advancement in offshore aquaculture, climate resilience and disaster preparedness, aquaculture as a pillar of national food security, emerging trends in sustainable aquafeeds, and last, precision aquaculture and smart farming system.
Now, I'm going to talk about technological advancement in offshore aquaculture. First, we have automated monitoring systems. Offshore farms now use real-time sensor and remote monitoring devices to measure key water quality parameters such as temperature, dissolved oxygen, salinity, and currents. Why does it matter? Farmers can detect changes instantly and adjust feeding, aeration, or position of cages before problems occurs. For example, satellite link buoy sensor transmit live data to farm operators via computer or mobile apps, reducing the need for manual checks in rough seas. Second, advanced cage mooring designs. Modern offshore cages are built from high durability materials like high density polyethylene, which is HDPE, and reinforced steel that withstand strong wave and currents. Why does it matter? Traditional coastal cages would collapse in open ocean conditions, but new designs ensure fish safety and minimize maintenance. Third, we have automated feeding systems. Offshore aquaculture use automated feeding machines that release feed based on the fish activities, water condition, and feeding schedules. Why does it matter? This prevents overfeeding, reduce waste pollution, and ensure the fish can receive the right amount of nutrition. For example, computer-controlled feeders connected to underwater cameras allow farmers to observe the fish behavior and adjustment feeding automatically. Number 4, or lastly, use of genetic and molecular biotechnology. Technologies like selective breeding, transgenic method, and DNA markers are used to produce fish that grow faster, resist diseases, and adapt better to offshore environments. Why does it matter? Stronger and more resilient fish reduce the risk of mortality and increase production efficiencies.
Next is climate resilience and disaster preparedness. First, by building elevated ponds, it is to help prevent fish loss and pond damage during heavy floods and rain. Second, using backup aeration system. It is to ensure continuous oxygen supply when power fails or heat increases. Third, stocking climate-tolerant fish species. It is to allow steady production despite sudden temperature or weather changes. And lastly is storing emergency feed and clean water. It is to maintain fish health during droughts or transport disruptions. Aquaculture as a pillar national food security. First, continuous fish supply. Aquaculture provides a steady source of protein all year around. Second is job creations. It supports farmers, traders, and fish processors across rural areas. Third, reduce import dependence. Local fish production lessens the need to buy seafood from other countries. And lastly is affordable nutrition. Make fish and seafood available at lower price for communities.
Here I'll be talking about the emerging trends in sustainable aquafeed. As aquaculture continues to grow, the demand for eco-friendly and cost-effective feed has become more important than ever. For the first one, using plant-based protein, the first trend is the use of plant-based protein such as soybean meal. the use of plant-based protein is to help reduce our reliance on fish meal and fish oil, which supports the conservation of wild fish population. Second one is the use of algae and seaweed. They are rich in essential fatty acid and micronutrients while also having a lower carbon footprint compared to traditional feed source. For example, microalgae is commonly used in the aquaculture. It is because alternative feed that used in aquaculture because its nutrient properties for the fish need. Next, insect meal is gaining popularity. Insects like black soldier fly larvae, also known as BSFL, and mealworm are high in protein and can be produced sustainably using organic waste material. For example, black soldier fly larvae, also known as BSFL, is one of the alternative feed that is used in some aquaculture practice. For example, in bees plankton, or more commonly known as Siamese fighting fish aquaculture, some aquaculturists are starting to use black soldier fly larvae as an alternative feed because of its sustainable source and cheap price. Then we have probiotic and enzyme. This natural additive improves digestion, which is enhance nutrient absorption, enhance fish growth, and support the fish gut health naturally without antibiotics. Lastly, circular economy feed ingredient. The circular economy approach promotes the use of agricultural and food industry byproducts in feed production. This reduces waste and contributes to a more improved sustainability in aquaculture system.
Precision aquaculture and smart farming system. Precision aquaculture means using modern technology to manage fish farm in a smarter and more efficient ways. It combines artificial intelligence, the Internet of Things, sensor and data analytics to collect and analyze real-time data from the fish farm. This system helps farmers make better decisions about feeding, water quality, and fish health. Instance, automated feeders release feed only when the fish are active, which prevent overfeeding and reduce waste. Water quality sensor continuously measure important parameters such as temperature, pH, and dissolved oxygen. And lastly, AI and camera monitoring system observe fish movement and behavior. They can detect unusual swimming patterns or slow feeding, which are early signs of stress or disease. This allows farmers to respond faster and reduce fish mortality. Move on to the next slide. Benefits of smart aquaculture. The use of smart aquaculture brings many benefits to farmers. It improves efficiency and reduces labor costs because most tasks are automated. It also helps to reduce feed waste, which lowers production costs and minimizes environmental pollution. By maintaining stable water quality, fish can grow faster and stay healthier. Smart farming also allows real-time monitoring so farmers can respond quickly when problems occur. Overall, precision aquaculture transforms traditional fish farming into a more modern, sustainable, and profitable system. This innovation plays an important role in ensuring food security and future of aquaculture. For a summary, modern fish culture has achieved great progress through the use of advanced technology, sustainable feed sources, and smart farming system. This innovation not only help farmers increase fish production and reduce environmental impact, but also strengthen food security and create job opportunities. With continued improvement and responsible practices, aquaculture will remain an important solution for providing healthy and affordable seafood.